Hello, ladies and gentlemen. We are back today learning about density. Um, we would normally have a lot of labs and things that go along with this, but you know, we'll do what we can here. Just learning how to calculate it. So, what is density? It's a physical property of a compound, so you can identify some things based on their density. You can tell if it's made of, silver versus platinum versus aluminum based on the density of those elements. So the formula for density is density equals mass over volume. Now we know from our metric system, we measure things in metric units here in the lab in chemistry. So mass is generally measured in grams. Volume is generally centimeters cubed. So remember, to get the volume of something, you need length times width times height. So that's cubic centimeters you get when you take those dimensions. You might also sometimes have milliliters if it's a liquid. So 1 cubic centimeter is the same thing as 1 milliliter if it's a liquid. So let's do an example of a problem here. Now, you guys are smart kids. I am sure that if I gave you a mass in grams and a volume in centimeters cubed, you could calculate the density, which of course would be in grams per centimeter cubed. Units are really important, people. But we're not going to make it that easy on you. We're going to give you problems where you have to think a little more. So this one says a piece of copper has a mass of 57.54 grams. Bam, I got grams. Fantastic. That should click. Oh, I got the mass right here. Then it says it is 9.36 centimeters long, 7.23 centimeters wide, and 0.95 millimeters thick. Calculate the density. So you have to, hopefully, you've noticed a problem already. I don't have anything in centimeters cubed, but I do have a length, a width, and a height. And I have 2 centimeter terms, but one of them's in millimeters. So how am I going to solve this problem? So think of a strategy. What are the steps I'm going to need? First, I need to get all my dimensions in common units. So I have the grams, I need some centimeters cubed. I've got 2 centimeters and a millimeter. I'm going to have to fix that. Then we're going to calculate the volume in centimeters cubed, and then we're going to calculate the density. So first, we'll start with that 0.95 millimeters. So if you remember your stair steps, kittens hate dogs because dogs can't meow. Remember, the millimeter step is just one away from the centimeter step. So you could use your stair steps and just say, oh, wait a minute, I'm on milli and I'm going to centi. So 1 centimeter is 10 millimeters. We're using dimensional analysis here, which we haven't talked about just yet, but we will. So in this case, you're dividing by 10. So the decimal gets moved over one, which is how we went from milli to centi. Move the decimal over, remember? So now we've got centimeters. Now let's turn that into cubic centimeters. So we're going to calculate the volume. We've got the 9.36 times 7.23 times 0.095, and we get 6.4 centimeters cubed. Now we can plug that into our density formula and take the mass divided by the volume, and we get 9.0 grams per centimeters cubed. Now, we might also throw some things at you. Oh, by the way, don't forget significant figures. So why does my answer only have 2 significant figures here? This one had 4, but this one had 2. So I'm limited. I cannot be more precise in my answer than I am in my least precise measurement. So if this one has 2 significant figures, I have to round this to 9.0. All right, I'm going to teach you a little math trick here for those of you who are not great at algebra or just want a shortcut. So you can take any 3-variable equation and put it into a triangle like this. When you're looking for one variable, just cover it up. So if I'm looking for density, I would take my hand and cover this up. and I would have mass over volume. So mass divided by volume. If I was looking for mass, let's say they gave me a density and a volume and wanted me to calculate mass, cover up mass. And I have density, and this time it's next to volume. So I multiply density times volume. If I'm looking for volume, I'll cover this up, and I'll have mass divided by density. So you can always use the equation and do the algebra, but just a little shortcut for you. So density is a property of matter that does not depend on the quantity of it. So it doesn't matter how much gold you have, it's always going to have the same density. Well, depending on the purity of it. Temperature is another thing. The temperature, melting points and boiling points are other properties that we can use to identify things too. Let's see, we'll just go over that. All right, so osmium is a very dense metal. What is its density its density in grams per centimeter cubed if you have 50.00 grams, so that's 4 significant figures, of the metal occupying a volume of 2.22 centimeters cubed. 3 significant figures. So right away I should be like, oh, my answer should have 3 sig figs. Now, I'm looking for density. I've got mass. I've got volume. So I'm just going to take the mass divided by the volume and get my answer, which I don't remember off the top of my head. There you go, 22.5 grams per centimeter cubed. I really should have logically figured that out, right? Makes sense. So there's the answer to it. And again, your calculator gave you this, but you can't have all these significant figures because your least precise measurement only had 3. So you round it to 22.5. Now, one of the ways in the lab, if you want to find the volume of something that is irregularly shaped, you can put it in water. So if I know that the start line, when this was water, let's say, and it was up to the 25 milliliter line, then I put this object in it and it jumps up to 33 milliliters. So then I know it went up 8 milliliters. So that is my volume, 8 milliliters, right? Or, as we said, milliliter is the same as a centimeter cubed, so you can use it for that. So here, what is the density of a 48-gram piece of metal if the metal raises the water level in the graduated cylinder from 25 to 33 milliliters? So pause the video, take a second to figure it out. Hopefully you're back with me now. So we had 48 grams, and then the water level went up from 25 to 33, so that's 8 milliliters, which is the same as a centimeter cubed. So my answer should be 6 grams per centimeter cubed. And you might say, well, why do I just have 6 and not 6.0 or something like that? When I subtracted 33 and 25, I just got 8 milliliters. So that was one significant figure, which now limits my answer. Here's another problem for you. So go ahead, pause the video, see if you can figure this one out. This time you're given density and you're asked to find the mass. So remember some algebra, or you can go back and do the triangle shortcut. And if you do, you should have gotten answer number 2. Again, we're limited to 3 significant figures. So even though your calculator gave you 614.25, you had to shorten it to 3 significant figures. And don't forget units on your answers. Here's another one for you. Give this one a try. So on this one, you're given the mass and you're given the density. So you're going to take mass divided by density, and that'll give you the volume. Oh, wait. Hold on a minute. Typed it in wrong. Which, oh, and then you have to turn it into liters. My bad. So when you do this, you take 575 divided by 1.05. You're going to get 574. And you're like, oh, Ms. Rector, that's not on here. But that is milliliters because you were using milliliters for your measurement. So the question asks how many liters. So when you turn milliliters into liters, you move that decimal over 3 places. Number 1 should be your answer. And that's it. All right. You guys have a good day.